Still playing with surds, the idea of rationalising the denominator. So here's one, 4 on root 2. How do you do it? Well, we multiply it by root 2, and that will make it a rational number. But of course we can't change the question, so we multiply the top by root 2 as well. So effectively we're multiplying by 1. So we end up with 4 root 2 on 2. Oh, but 2 and 4 cancel, 2 root 2. Now if it's something like this, you don't have to multiply by 2 root 5. I mean you can, it'll still work, but it'll mean you'll end up with having to do some cancelling later on. Just the third part will do. So just root 5 on root 5, there we go, 3 root 5 on 10. So that's if there's a single term in the denominator. Of course then we end up with these ones, where there's 2 terms in the denominator. We multiply by, so the conjugate, creating difference of 2 squares, because we know when we got difference of 2 squares, we're going to end up with a rational number, because we're going to have a squared minus b squared. And so we end up with 2 minus 1 on the bottom, which is of course just 1. So we end up with 3 root 2 plus 3. Much more fun when there's also a surd on the top as well. So on the top we've ended up with a perfect square. On the bottom the difference of 2 squares. Look, be real careful with things like this, because it's so easy to do things like, root 3 times root 3 is 9, or 2 times 2 is 2, because you're used to seeing the square root sign there. So be careful. But in this case we get 4 minus 3. All right.